Okay, in this video, we are going to go over the Pythagorean reciprocal and quotient properties. So we are going to go over the derivation of all three of those. All right, so our objective is to derive algebraically three kinds of properties expressing relationships among the trigonomic functions. Specifically, these are the three different properties that we are going to derive. Some of them you have seen before. So the reciprocal identities, we've talked about those in length many times. The quotient properties you're pretty familiar with. And in our previous video, we talked about the Pythagorean identities. So we're just going to go into the derivation of them, and then we'll do a couple of practice problems, well, you will on your own at the end. All right, so we're going to start with the reciprocal properties. And when you look at the reference triangle, you can find the 6 ratios. So here's our reference triangle, and we have named those before. So one of our ratios is opposite over hypotenuse. Well, then the reciprocal ratio would be the hypotenuse over the opposite. We have the adjacent over the hypotenuse over the adjacent, and we have opposite over adjacent over opposite. So those are our 6 trig ratios, and we have named those sine, cosine, tangent, cosecant, secant, and cotangent. What is special about sine and cosecant, or cosine and secant, or tangent and cotangent? So let me see if I can get this pen up and going. So what I'm asking you here is, what is special about sine and cosecant? So, oh, I didn't mean to put an equal sign there. And cosecant. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. And so what is special about these is that if you took sine and you put it under 1, so 1 over sine of x, that's the same thing as 1 over opposite over hypotenuse. Well, 1 divided by opposite over hypotenuse, if we cross multiply here, we get hypotenuse over opposite. And so the special thing is that if I were to put a 1 above sine, cosine, or tangent, I'm going to get its reciprocal. That's pretty cool. So they're reciprocals. That is what is special about these. They are reciprocals. Okay, so our first reciprocal identity is secant of x equals 1 over cosine of x. Our next one is cosecant of x is 1 over sine of x. And then we have cotangent of x equals 1 over tangent of x. So those are our reciprocal identities. And of course, you could also write these as, let's see if I can find my pen here. You could say cosine of x is 1 over secant of x. You could say sine of x is 1 over cosecant, and you can say tangent of x is 1 over cotangent. So you can write it either way. That's pretty cool. What this does is it allows us to start transforming equations into things that are a little bit prettier. We like things in terms of sine and cosine. We're familiar with sine and cosine. We know how to graph sine and cosine. We know its behavior. We like them. And so now if we have something in an equation that's secant, we can rewrite that in terms of cosine. It makes our life a little bit easier. You're going to want to memorize these bad boys. Yep, sorry about that. Okay, we are going to move on to our quotient properties. So our quotient properties deal with tangent and cotangent. So if you divide sine of x by cosine of x, you get a pretty interesting result. So let's see, what does that look like? Let's go ahead and put in sine of x, and then we'll put in cosine of x. And you can see these graphs and you know what they look like. And let's divide them. Whew, that graph looks familiar. That graph looks like tangent. That's what it is. So we call this a quotient property because quotient means to divide. So taking sine and dividing it by cosine gives us the quotient tangent. This is a quotient property because we are dividing them. Oops, I don't know what I'm doing with my animations, guys. So the quotient property was born. Tangent of x equals sine of x over cosine of x. It's pretty neat. So our first quotient property is tangent of x is sine of x over cosine of x, which again, as I said earlier, we really like things to be in terms of sine and cosine. We know how sine and cosine behaves. We know how to graph them. They're pretty. And so we can now replace any tangent in an equation with sine divided by cosine. Of course, you have to keep that domain where x cannot equal pi over 2, because at pi over 2, cosine equals 0, and then every pi thereafter. The other quotient property is cotangent is cosine of x over sine of x. And the reason why is because this is a reciprocal of this. And reciprocal means to flip. And this one, our domain is x cannot be pi because that's when sine equals 0 and any after that. Any pi after that. You're going to have to memorize these two. Sorry. All right, so now we are on to our Pythagorean identities. And if I'm moving quickly, go ahead and rewatch this video or comment below and ask questions, whatever you guys need. So this figure here shows an arc of length x. So this right here is our arc, and we are calling that length x. This is just a piece of the unit circle. It's on the UV coordinate system. And this point here is going to follow the Pythagorean theorem. So if this is 1, then we know that this squared plus this squared has to equal 1 squared. So what we know is that u squared plus a v squared equals 1. So we also know, because this is the unit circle, that u represents cosine and v represents sine. So if we replace our u with cosine and we replace our v with sine, we get cosine squared of x plus sine squared of x equals 1. And that's our Pythagorean property. That's our Pythagorean property, and we know this is true every single time. We derived it in an earlier video. We showed how this is true. So that's our Pythagorean property. And now we can use this whenever we see cosine squared plus sine squared, we can just replace it with a 1. 1 is a heck of a lot prettier. We can also rearrange this. We can say that cosine squared of x equals 1 minus sine squared of x. And we can rearrange it by using algebra. I just subtracted a sine squared from both sides. We could also rearrange this to know that sine squared of x equals 1 minus cosine squared of x. And what I did was I just used algebra and I subtracted this cosine squared of x. So these are all a part of the Pythagorean identity. And now if I have a 1 minus sine squared, I could replace it with cosine squared. If I have a 1 minus cosine squared, I can replace it with sine squared because these are equivalent. This property is true even if x is in a different quadrant, and the reason why is because a number squared is still going to be positive. And that's the really cool thing about the Pythagorean property. Okay, so like I said, we can rearrange that to get more Pythagorean properties, which we just did on the last slide, but let's do it again. Oops, sorry. Fumbling through this. So we have cosine squared of x plus sine squared of x equals 1, which means that cosine squared of x equals 1 minus sine squared of x, and sine squared of x equals 1 minus cosine squared of x. It's pretty freaking cool. Right now, this might seem like, why are we doing this? This is a whole lot of memorizing. What am I going to use this for? In the next video, we will start actually applying this. So right now, it's just understanding where are these identities coming from, why do they work this way, and now we're going to start, well, next video, we're going to start actually substituting these in. Okay, so let's derive some more. So we are going to start with our basic Pythagorean property. And now we're going to use what we know about tangent of x to derive another one. So we know that tangent of x equals sine of x over cosine of x, which means that if I can get a sine of x over a cosine of x here somewhere, I can have a tangent in there. So what I notice is that I have a sine squared. If I divide sine squared by cosine squared, I will get a tangent squared. Now, algebra's golden rule says what I do to one side, I must also do to the other. And so what I'm going to do is I'm going to take this entire thing and I'm going to divide by cosine squared of x. And algebra's golden rule says what I do to one side, I must also do to the other. And now I'm going to simplify. Cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 divided by cosine squared, well, 1 divided by cosine is secant. So 1 divided by cosine squared is secant squared of x. There is another Pythagorean identity. And of course, this can be rearranged. Maybe you want to have 1 equals secant squared of x minus tangent squared of x. All I did was I subtracted this tangent squared over to the other side. And so if I ever see this as in an equation, I can replace it with 1. It's no longer this ugliness. It is 1. That is really cool. Okay, let's do what we know about cotangent. So cotangent of x equals cosine of x over sine of x, which means if I can get a cosine of x in here somewhere, a cosine of x over sine of x, then I'm going to get a cotangent. So let's try dividing this whole thing by sine squared, because cosine squared divided by sine squared is cotangent. So let's start again. We're going to have cosine squared of x plus sine squared of x equals 1. I'm going to change my color, and let's go ahead and divide this bad boy wherever my cursor went. Where's my cursor? Maybe. Oh, maybe it's not working anymore. Uh-oh. Oh no! Ah! Divide this by, oops, sorry guys, I'm sorry that you have to watch me struggle through this. Sine of x. In algebra's golden rule, what you do on one side, you must do on the other. Cosine squared divided by sine squared is cotangent squared. Sine squared divided by sine squared is 1. 1 divided by sine is cosecant, so 1 divided by sine squared is cosecant squared. And there we have another Pythagorean identity. That's really cool. And again, you could rearrange this into all sorts of different forms. Crazy, super crazy. But it's really fun. You can just play around with these things. You can manipulate them. You can manipulate math problems. Don't manipulate people. So our first Pythagorean property was cosine squared of x plus sine squared of x equals 1. We then derived 1 plus tangent squared of x equals secant squared of x. And then we derived cosine squared of x plus 1 equals cosecant squared of x. And all of these can be rearranged. Are you having fun yet? All right, so here's your assignment. Go ahead, pause this video, and work out this assignment. And I hope this video was helpful.